now worked extensively on the California Water Plan update and the advancing integrated water management in California. And I'm really pleased to have the opportunity to share with you one of what I think is the cutting edge and great potential integrated water management strategies that we have available to us for California, and explain why it's so important to advance this strategy, and what DWR and other state agencies are doing to do so. So what I like to share with folks as part of the context is that California has been plumbed for many years around a snowpack dominated hydrology. And many of our reservoirs, much of our water conveyance systems have been designed, built, and operated to really take advantage of our largest surface storage reservoir in California, and that is snowpack. However, we have observed and understand that California water has and is becoming even more a tale of two extremes. So as a Mediterranean climate, that's not in and of itself unique. California and other Mediterranean areas or climate areas in the world do experience wetter and drier extremes. And in fact, it's rare when we do get average conditions. So along the top of the slide, you'll see indications on the top of flood events in the recent past, and on the bottom of that timeline, drought events. And so you'll see that they are reoccurring and quite numerous. And in fact, in some years, we experience both extremes. And with climate change, we are observing our reduction of snowpack, earlier snowmelt, which is modifying the typical hydrographs that we've experienced and documented in California. So this slide shows model simulated data for both historical hydrologic conditions in California and climate change scenarios. So the silver blue or gray lines are an indication of the historical scenarios, and the amber and browner lines are the climate change scenarios. So 2 or 3 observations just jump out. One is that with climate change scenarios, we see that the peak flows in the winter are shifting earlier and higher. At the same time, our summer hydrology, we anticipated becoming drier than what we have observed historically. And then the thick lines are the medians of many, many simulations. And then the individual lines, which are quite dramatic, are each particular scenario that we ran. So we see that we're going to experience more peak flows in the winter and then drier conditions in the summer. Underlying those conditions, which actually have and will continue to cause a lot of challenges in California, are some root causes that we have to deal with as we move forward to do more integrated water management. One is that we're very siloed and decentralized in the way water is managed and decisions are made. In fact, there's somewhere around 2,500 different entities in California that make decisions about flood management, water supply management, water quality management, ecosystem management. And many of those decisions are at the local level, and there hasn't been a lot of communication, coordination, and collaboration amongst those entities, or at least sufficient for the task at hand. Part of that siloing also goes into our regulatory institutions, so that we have regulations that are being adopted by different agencies and entities, and they're being kind of optimized for the sector or the area of their authority and responsibility. And what happened and is happening is that those regulations are not aligned sufficiently to allow aggressive and extensive integrated water management project implementation. So, and the ones that we are and have attempted, and this is the big we throughout California, are very time consuming and costly to go through the various permitting processes. At the same time, to do integrated water management, we need better information, and information that is intended for an integrated approach. And so data exchange, data transparency, better data documentation, and data sharing is going to be needed to make decisions around integrated water management. And then last but certainly not least, society and end users of water and have to commit and agree to the necessary funding that we're going to need to address these challenges. So over the last 10, 15 years, there have been a number of efforts at the state level to address these underlying root causes, as well as advancing an integrated approach to water management. Governor Brown administration put together a water action plan that has helped coordinate amongst multiple state agencies and departments around water management. In 2016, the state passed the Sustainable Groundwater Management Act, which is a game changer. So in the early 1900s, the state of California passed a surface water rights system. It took us about 100 years to get around to doing the same for groundwater. And prior to 2016, state government had very little authority to manage or help people manage their groundwater resources. And so since 2016, the state actually has a responsibility to help make our groundwater resources more sustainable and in conjunction with our surface supplies. In 2017, the Central Valley Flood Protection Plan was updated, and rather than a silver bullet approach or looking at a few options, it has taken a portfolio management approach and laid out a series of strategies, projects, and programs that need to be advanced in parallel to reduce the flood risk that we experience today, and we will experience even more so in the future with climate change. And then the California Water Plan, which DWR is responsible for updating every 5 years, is now being updated for the 2018 update. Within the next few weeks, we'll be putting out a public review draft of the 2018 update, and this update is further reinforcing the need for a coordinated, more aligned, and an integrated approach to water management. All of these efforts are really wanting to incentivize and promote the implementation of more multi-benefit projects that include ecosystem enhancements and that really look at sustainability as the criteria for success. So I've mentioned the word alignment and integration several times. This graphic on the slide, this flower graphic, really identifies in the outer petals the major water management sectors that many of us are familiar with. And traditionally, much of the activity that has occurred is on the outer periphery of each of these petals. And you'll see that in some cases, even then, 2 or 3 petals may overlap with each other, indicating that some projects do and have provided multi-benefits. To really be more sustainable with our water resources in California, we need to design, plan, and implement projects that are really more in that center circle, where we get maximum and multiple overlap amongst the water management sectors. And more, I like to use the term co-management. We have to really do much more co-management of the various sectors. And what that means is we have to collaborate across sectors. We've got to bring multiple disciplines to bear when we plan, design, and implement our multi-benefit projects. And then this also affords us the opportunity to knit together multiple funding pots. And so each sector has access to various funding resources. And by doing multi-benefit projects, we're able to leverage those resources in concert to advance the multi-benefit projects. So FloodMAR is, in my mind, a really good example of a strategy that lives in that center petal of that flower and really calls for co-management of our flood management, our groundwater management, and our ecosystem management systems. And what it's really about is taking advantage of the highest peak flows, which at this time are really not used or allocated to water users, because at those points in time, most people really haven't been set up to take advantage of those flows. We built levees to, in some respect, keep our flood management system and our groundwater management systems separate and apart. What we have to do moving forward is design and engineer and use science to work across those levees, particularly in utilizing these higher flood flows to recharge and refresh our aquifers on agricultural and working lands. So FloodMAR, what's neat about it, as I mentioned, it's inherently an integrated approach. In fact, I think you have to go out of your way to do a FloodMAR project that doesn't provide many of those benefits. The other neat thing about it, to make it work in California, is it's got to be a voluntary management strategy. And by that, I mean taking a public-private partnership approach. Much of the ag and working lands are under private land ownership. And the landowners own a very important asset, and that's the recharge, the infiltration surface into our aquifers. At the same time, they are taking activities that use groundwater and adjacent surface waters. So we have to find a way to do FloodMAR to engage the private sector along with government to make this work. The other neat thing about FloodMAR is it's scalable. In fact, DWR did not invent FloodMAR. FloodMAR type projects have been going on for the last 25, 30 years in California, and it's been done on a very small scale, case-by-case basis, where a farmer next to a stream has had the infrastructure to be able to pull off some of those higher flows and spread it out onto their ag lands in the wintertime when many of them are not in the growing season. At the same time, FloodMAR could be implemented by groundwater sustainability agencies at a sub or full groundwater basin scale. And by coordinating and collaborating with other stakeholders on a regional scale and even a watershed scale, we could envision FloodMAR projects. And then ultimately, this is seen as an important addition to California's water portfolio. And the important note there is this is not a silver bullet. We are not under the illusion that if we do FloodMAR, all of our water management challenges will be taken care of. Yet, it will really take the pressure off of strategies or other actions that might not be as palatable. A case in point would be ag land retirement. So, as I mentioned in a prior slide, the state has actually taken some actions from 2017, which is again right there after the SGMA legislation passed, to take actions to advance the FloodMAR concept. I mentioned the 2017 Central Valley Flood Protection Plan update. Also, DWR has been working on a system reoperation study for a number of years. We put out the Phase 3 report last August, and in that report, we put recommendations for the next phase, which we're working on right now, to do more studies and exploration of how we could advance FloodMAR. The State Board of Food and Agriculture and the Department of Food and Ag recently, last fall, held a very large symposium here in Sacramento about what could be done to advance managed aquifer recharge on ag and working lands. And out of that event and subsequent dialogue and conversation, the State Board of Food and Ag, and I'm going to pull up one of my props here, sent a letter to the governor, Governor Brown, along with a half a dozen or more recommendations for what the state government in particular could do. And that includes Department of Food and Ag, Department of Water Resources, the State Water Resources Control Board, and Department of Fish and Wildlife to really implement FloodMAR at more of those multiple scales, not just on a farm-by-farm basis, but maybe more on a groundwater basin or a watershed basis. And then the water plan update, which I mentioned, the public draft will be coming out. There are specific recommendations in there for advancing this strategy and similar approaches as we do our work in the future. So the graphic on the bottom of the slide is a typical hydrograph. And the point that I wanted to make here is some of you may have heard about the study and report that DWR put out last year called Water Availability for Replenishment of Aquifers. And this graphic just conceptually shows that when we did that study, we really focused on existing and low-hanging fruit infrastructure and existing institutional arrangements. So you see two horizontal lines across this hydrograph. The bottom one are the minimum in-stream flow requirements by the Department of Fish and Wildlife and the State Water Board. The upper horizontal line was what we, DWR and the investigators identified as the diversion capacity that is or could be reasonably utilized to take the water between those two horizontal lines and apply it to agricultural and working lands. what's striking about this graphic is there's a lot of hydrograph above that top horizontal line. And what FloodMAR is working on and will continue to explore is how could we divert some of the highest parts of those peak hydrographs for groundwater replenishment, and do it in a way that provides floodplain ecosystem benefits and at the same time does not adversely affect aquatic habitat and fish in the adjacent streams. So DWR, kind of starting with that symposium, groundwater symposium last year, put out a draft of, here's another visual. This is the FloodMAR Whitepaper, and we just put this out last month in June in final as a framework and a body of knowledge that we were able to pull together from many experts and many people in the field on what do we know about the benefits of FloodMAR. These list many of the public benefits, and I'm not going to read through all those, but I think you will appreciate that it's very integrated. I mean, I think it touches every sector of water management. And on top of this, there's also the private benefits of FloodMAR. So water that is recharged using peak flood flows that are later taken out for private ag and urban use would be the private benefits. Now, some of you may have heard that Proposition 1 has $2.7 billion of funding for advancing storage projects in California. And that's the full gamut of surface, groundwater, conjunctive water management type projects. The stars that you see now on this slide are the benefits, the public benefits that are called out explicitly in Proposition 1. So projects that provide one or more of these public benefits were eligible to apply for getting some of that public funding. Now, what's very conspicuous is aquifer replenishment, which is a green infrastructure that is, in that sense, it's the vessel that holds groundwater, environmental asset, is missing from the FloodMAR, the public benefit list. And so the reason for that is when the Proposition 1 language was written, it was the pre-SGMA before 2016 demarcation. And so it was not, again, on the radar for state benefits. In the white paper, you'll see a description of 8 implementation factor categories that are on this slide. And under each category are multiple considerations or aspects of those. And I'm not going to read through all of those. I encourage you to take a look at the white paper, and there's discussion about these various categories. We also, in the white paper, working with others, have identified what are the potential barriers that make implementation of FloodMAR at those various scales difficult today. And we've grouped them by the governance and coordination amongst the water management sectors, legal issues like water rights, regulations, and permitting, policy issues like what is a public benefit, what is a beneficial use, are aquifers green infrastructure, should we treat them as an environmental asset, and then how would we go about compensating private landowners to incentivize their participation in a more scaled up FloodMAR program. And then ultimately, all those implementation factors that are needed to work, one would need to work through to do a FloodMAR implement a FloodMAR project. So the work that we've been currently doing, and at the end we're going to show you the web link to the FloodMAR webpage. Everything that, all the documents that I've shown you and will show you are posted there. One is this FloodMAR fact sheet, and it gives you kind of a two-page summary of FloodMAR along with the URLs where you can get this information. I mentioned the white paper, and the one other document that I'll actually talk more about in a minute is a discussion draft of what we're calling a draft research and data development framework. And so just hold on and I'll come back to that. Out of that, in the next couple of months, we want to convene a research advisory committee with multiple subcommittees to help us work on this R&D framework. As part of the system reoperation study that I mentioned, DWR has also embarked on a Merced River Basin conceptual study and a Tuolumne River climate vulnerability study to begin demonstrating and piloting the various factors that are identified in the white paper. So the R&D framework, putting that together, motivations were to really, as I mentioned, a lot of people in academia and different agencies and NGOs have been, and private landowners have been working on different aspects of FloodMAR. DWR wanted to kind of get out there and pull this knowledge together and come up with a good inventory of the work that's been done and research needs that still need attention. We want to use that to develop or identify who are the technical experts that we need to engage to work on this. As I mentioned, to convene this research and advisory committee. And what we're going to task that committee to do is develop a more detailed R&D plan for FloodMAR. What would we need? How much need to do? How much would it cost? And then begin identifying funding opportunities to go out and actually start doing some of this R&D work. We would like to use DWR's FloodMAR program to be an ongoing repository, place to go to see what's available. This could also help people who want to implement FloodMAR projects on designing and implementing their projects. So this slide just wants to demonstrate, I want to demonstrate that we've identified 14 subcategories of research that will be part of this research advisory committee. And we intend to have each of these subcommittees convene with the experts of interest to begin working on the R&D plan. I mentioned the Merced River FloodMAR study, and one of the goals of this study is to actually demonstrate how the various factors and concepts in the white paper can be used to advance FloodMAR on the ground. It's going to actually take prior studies that have looked at the surface system reoperation, other studies that have looked at the groundwater management opportunities, and bring them together into one more integrated study to see what more we could get out of these same the same infrastructure and the same operations or activities to get multi-benefit multi-benefits. And the approach we're taking on this is we're going to do some study with the existing operations and infrastructure, what we could get with revising operations. For instance, what if rule curves were changed as we recognize a changing hydrology with climate change? what could that give us with the existing infrastructure? And then at the third level, look at the revised operations and what more conveyance and storage infrastructure as far as groundwater could give us moving forward. On the Tuolumne, we're actually doing what my colleagues call a bottom-up analysis of climate vulnerability, because what we'd like to do, demonstrate that we need to do this for every major tributary in California to get a handle of what our vulnerability is on the flood side and what opportunities that might provide us to replenish groundwater. So this is my last major slide about next steps. So we've done some good work over the last year and a half. We want to continue. We're getting some momentum with the white paper out there, the draft R&D framework. We are going to probably latter part of August or so have a public workshop to begin engaging stakeholders, academia, investigators in the R&D framework work. We are right now, and I mentioned, it's a draft R&D framework. So everyone on this webinar, that is an open invitation to please take a look at that and send us comments. Are the categories sufficient? Are we missing an area? Are the topics under the various categories sufficient? We're going to take those comments and we're actually going to give that to the Research Advisory Committee as their first assignment. So take the draft R&D framework, take the comments we receive, and revise the R&D framework as your roadmap to developing an R&D plan to get that ownership and the additional expertise. We're going to work on completing the Merced River and the Tuolumne River climate vulnerability study by next spring and use that information to generate more interest and knowledge. And ultimately what we want to do, if you've been following the Sigma process, by 2020, and in some cases 2022, these groundwater sustainability agencies have to develop a groundwater sustainability plan. And in that plan, they have to demonstrate what they need to do to bring their basin into more sustainable balance. What we would love to see is this FloodMAR information helping these GSAs include FloodMAR as one of their tools in their toolbox for balancing their basins. And that rocket ship that went off in the corner there, that's just my way of underscoring conceptually the science and the engineering is not, we can overcome that. The tough part are all of the institutional arrangements and past practices that we're going to have to work on. So I consider FloodMAR in that respect a moonshot for California, and yet it's essential for us to do what we need to do to manage climate vulnerability and balance our future water demands. So with that, I'm happy to take questions. Thank you.